So let's start talking about clouds. And the first thing I need you to do is label a page on the top of your notebook in big bold letters, clouds. You're going to see these questions come up and they're going to be numbered. And you need to copy these questions down as I go through the presentation. This will serve as your guide to the information that you need to get out of this video. First of all, we're going to define what clouds are. I know you know what they are. You can picture them, you can visualize them, but let's make a scientific definition of what clouds are. And here we go. Clouds are visible collections of water floating in the air. Once again, very carefully, clouds are visible, which means they can be seen. Clouds are visible collections of water that are floating in the air. Now, precipitation is what falls from clouds. That's water that's actually falling to the ground. You can see precipitation, rain, sleet, snow, whatever, but it's not a cloud because it's not floating in the air. So how is a cloud different than humidity? The difference between a cloud and humidity is the total amount of water in the air, but we really can't see it because it's all still individual drops, whereas a cloud is a mass of water that has been stuck together so that we can now see it. Now, two things have to happen in order for a cloud to form. First of all, number one, we've got to have water in the air. Remember that a cloud is a visible collection of water, so if there's no water in the air, you can't have a cloud. The second thing that has to happen is the water has to get cold enough to condense so that it starts to stick together. That's that difference between humidity. You can have really high humidity and you don't have a cloud because it's not stuck together. You can't see it. Consider these two water bottles. The water bottle on the left is cold, and when air and water in the air touches that water bottle on the outside, you get these little drops forming on the outside. You get the sweat on the outside of the cold water bottle. Well, that's water in the air that when it touched the cold water bottle, it got cold and it condensed. The water bottle over here on the right is not cold. It's straight off the shelf. So that when water in the air hits this water bottle, it doesn't get cold and it therefore doesn't condense, and we can't see it on the outside of the bottle. So that's kind of similar to what has to happen in order for a cloud to form. Now here's a little video demonstration. And I'm in Fairbanks, Alaska in the wintertime, and I've got a cup of boiling hot water. You can see it is boiling hot. Now that in and of itself is not a cloud. We've got to put the water in the air, and then it has to be cold enough for it to condense so that we can see it. And there we go. There's our cloud. That's a very dramatic video that wouldn't work if I were here in Georgia because the air there was so cold. As soon as I threw the water into the air, it condensed, stuck together in big enough clumps so that I could see it, and that's what a cloud is. So I've been throwing out this term condensation. We need to define that. And you've had this in physical science, but just as a reminder, condensation is the process of water, vapor, or water in the air turning back into a liquid when it gets cold. So we know water goes up in the sky, and we know at some point we'll get a cloud because the water, gets cold and then starts to stick together. But where does that happen? Well, clouds happen up here. Clouds happen up high in the sky. Why? Because that's where it's cold. And we know that the higher up you go, the colder it is. So the more likely water is able to condense and form a cloud. This is why clouds happen up in the sky, away from the ground, because that's where it's cold enough for the water to condense and form a cloud.
So this video right here can give you a clearer idea about how water condenses and the effect that elevation or altitude and temperature has on the formations of cloud. You can see back here, here's a cloud. So there we know the water is cold enough to condense and start to stick together and form those droplets that make up a cloud. Down here, notice you can see the ground. So down here it is still warm enough for water to be evaporated. So right at that point, going up the mountain, that's the point where it all of a sudden gets to be cold enough for the water to start to condense and stick together. As you can see, it's sunny right here, and it's about 80 something degrees, about 84 degrees. Now, I'm about to get on that train right there, and I'm going to go to the top of Pikes Peak, which is about 14,000 feet in elevation. And then we'll check and see what the conditions are like there versus here. So now I'm at the top of Pikes Peak, and I'm 14,000 feet up. And now it's 43 degrees and cloudy/rainy, because at this elevation, all of the air coming up is having its water cool so much that it condenses to form the clouds and then rain.
So here you can actually see it. There's the actual point up the mountain where it is now cold enough up here for the water to condense and then stick together and make a cloud. Down here at the lower elevation, it's too warm and the water is able to stay evaporated. It doesn't condense and stick together and form a cloud. So we need two things for clouds to form. We need water in the air in the first place, and we need it to be cold enough for that water to condense and stick together so that we can see it. Now, pressure makes a difference as well.
So let's talk about clouds. And by now you should understand what a cloud is. It is a visible collection of water in the air that we can see. And it comes from water, like back here in the ocean, that evaporates and goes up in the sky until it gets cold enough to condense and starts to stick together, and that's what forms a cloud. Well, you can see behind me, I've got a nice big source of water, yet I have absolutely no clouds in the sky. So there's got to be something else in play here that determines if you have clouds or not. And that other factor is air pressure. Now, air pressure is the force or the push caused by the weight of air. Behind me here, we have a nice high pressure day. The pressure of the air is high. There is a lot of air right here, and it is pushing a lot, and it is pushing down on the ocean. Well, that keeps the water in the ocean from evaporating. So if the water in the ocean cannot evaporate and go up into the sky, it can't get cold and condense and forms clouds. So a high pressure or high pushing from air means you're going to have nice sunny skies with very little clouds, and hence a very low chance of precipitation.
So let's talk about the methods. There are a couple different ways that this process happens, and we're going to be sketching some diagrams and describing how clouds form, because there's more than one way that this process can happen. Number 6, this is going to be convection. And what happens is with convection is the sun comes out and it makes any water down here on the ground get hot, and then it evaporates and gets up here in the sky somewhere where it gets cold, starts to stick together, and makes a cloud. This is the process of convection, which is like a transfer of heat, remember, by water or air. And that's what's going on here. The sun is making the ground hot, which causes the air to rise, takes the water with it to the point where it condenses, forms a cloud, and then we can see it. This is primarily how we get clouds in Georgia in the summertime. It's pretty much the only way, because we know in Georgia in the summertime, that sun's really hot. And all that sunlight beats down on the ground, and we have a lot of water in our air anyway, and that air goes up, and eventually you'll get to some point during the day where enough air has gone up that it sticks together and makes a cloud.
So here we've got some water, and near that water is evaporating, which you'll notice there's no clouds up in the sky. But as we turn over this way, notice that we've got clouds forming over the land. And that's because once the air gets over the land is hot. Well, the hot air rises and takes that water up in there into the sky where it's cold enough to form clouds.
Now, question number 7 is, when do you think this is most likely to happen? Like, when are you going to get clouds formed by convection? Well, think about the process here. When are we going to have the most sunlight? When is the area down here going to have been hot enough? When would we have gotten enough water to go up here to have enough that we eventually get a collection that we can see? Well, this takes time. This process forms clouds primarily in late afternoon, because that's when the sun has been hot enough and has been making water evaporate all day, so we finally get enough water up here collecting that we can see it. And if you think about Georgia's summer days, we almost never have clouds in the morning. But by late afternoon, we start to see some of these white puffy clouds pop up because the sun has now made enough water to evaporate to the point where we can see it. Convergence. Convergence is when we get two winds that blow towards each other. When they blow towards each other, they hit each other and they can only go one direction, and that's up together. Well, all this wind has water in it because all air has water in it. So we wind up with a bunch of extra water up here where it's cold enough, and then it starts to stick together and we can see it. And this is clouds being formed by convergence. The state of Florida is famous for having its clouds formed by convergence because they very typically get a sea breeze on this side, but because Florida's peninsula, they get a sea breeze on this side, and these sea breezes meet here over the state of Florida, and the air only has one way to go, and that's up. And it takes the water that is collected over here and the water is collected over here, takes it up in the sky, they meet, they condense, and they form clouds. Now, question number 9 is, when do you think this is most likely to happen? When does Florida get its clouds, especially in the summertime? It's the same answer. It's late afternoon, because we know that's when the sea breezes have been strongest, and that's when we're going to get the most convergence of air and the most water going up in the sky to make clouds. If you've ever been in Florida in the summertime, you know it's pretty much going to rain every afternoon. 3, 4, 5 o'clock, you're going to get thunderstorms because you've had so much air converging from these sea breezes, and you get such clouds that grow and to the point where they can't handle their water anymore, and they drop it as rain.
So let's talk about the formation of clouds. Clouds come from water that gets up into the sky by the process of evaporation. Well, behind me here I've got the ocean. This is the Pacific Ocean. It's pretty warm, so that water's evaporating pretty good. I've also got a nice onshore breeze bringing all of that nice wet air to me. But notice it's perfectly sunny here. There are no clouds because there is no mechanism to make that water go up to the point where it gets cold. Now, if I turn around and I look inland, back there is the volcano. That's the Mauna Loa volcano. It gets up to about 12,000 feet. And as the water in the air is moving towards me and goes past me, it hits that mountain and it has to go up the mountain. Well, you know that higher up it is colder. And you can actually see that point where it becomes cold enough for all of this water that is coming from the ocean in the air to get up there and turn to clouds and get rain. It rains a lot up there because it's always cold up there. And all of this water from the ocean winds up there where it gets cold, condenses, makes clouds, and it rains. Right here where I'm standing, right along sea level, there's nothing to make the air rise, go up, take that water up high where it gets cold and makes clouds and subsequently precipitation. This process here is known as orographic lift, O-R-G-R-A-P-H-I-C lift. It's just a fancy way of saying that mountains make air go up to the point it gets cold enough where the water condenses, forms a cloud, and then eventually makes precipitation.
So here's our diagram for orographic lift and a brief description of what I just said, a little bit simpler to put in our notes.
Remember that you can tell a lot about how much precipitation an area gets based on the size of the trees and the amount of trees that you see in that area. And as you can see here behind me, we got a pretty big tree and we've got all kinds of trees back there. So this is obviously an area where they get a lot of precipitation. You can even see the result of that precipitation back there. There's a pretty good sized lake of standing water. So what we see in this picture tells us that at this location, we get a lot of precipitation. All right, so now I have only come about 20 miles from that previous location, and let's take a look at this area here. Once again, the amount of precipitation an area receives is usually indicated by the size and the amount of trees that you see. And you'll notice here, there aren't any trees. There's hardly any green vegetation at all. You can see this is a desert. This is an area that receives very little precipitation, yet I am only 20 miles from my previous presentation. The question is, how do we explain that? How can you only go 20 miles and have such a distinct difference in the amount of precipitation?
Well, what's happened here is my wind is coming this way and picking up water, and it's going up the mountain, and at someplace up here on the mountain, that air gets cold and the water gets cold, and we get a cloud. So we get rain. That's what's happening here. This location is on this side of the mountain. The problem is now, once the rain gets over the top of the mountain and starts going down the other side, it actually starts to heat up, because we know it's going downhill, and when you get lower, it's hotter. Well, if the air is getting hotter, that's not going to help make water condense and make clouds and precipitation. So you wind up with an area that doesn't get much rain, because the air is warming up, which is counter to making clouds and rain. And you'll notice on this side, when I was at this location, my temperature in my car was 60 degrees. It was relatively cool for a summer day. But yet when I got over here, 20 miles away, it was 78 degrees. It was so much warmer that any water left in the air couldn't condense and form a cloud. This is what's known as the rain shadow. The rain shadow is the side of the mountain that doesn't get the water. And you can see it in this picture right here. This is Lake Tahoe. The Pacific Ocean wind blows this way. And right here is the top of the mountain. So they get crazy amounts of snow over here as the water is going up the mountain and cooling and condensing and falling as rain and snow. Once you get over the top of the mountain and the air starts to go downhill, it warms up, which means it's not going to condense, so you get no clouds and you get no precipitation. This area back here is called the rain shadow. It's the side of the mountain that doesn't get much clouds or precipitation. Number 12, another way in which clouds can form is called lifting along fronts. Now, you recognize this map. You recognize we have these different air masses that are moving around our country, and sometimes they butt heads. Sometimes, one air mass is coming this way and another air mass is coming this way, and they bump into one another. Well, that greatly affects the weather in that particular location. A front is where two air masses meet. And what happens is our warm air, which generally has more water in it, remember, because warm air can hold more water than cold air, and our warm, wet air coming from that maritime tropical system out of the Gulf is moving over Georgia and trying to move up to the United States. Well, if we get a continental polar air mass that is trying to push its way south, and these two meet, well, warm air rises. So what's going to happen is the warm air gets pushed up over the top of the cold air, which of course makes it colder, and it's already colder up high. And so my warm, wet air condenses to form a cloud. Now we're going to list and describe the major types of clouds. Those are the processes by which they form, but they don't always form the same type of cloud.
So those are clouds. Remember that a cloud is a visible collection of water suspended in the air. Those, more specifically, are what's called cumulus clouds. And cumulus comes from an old Latin word that meant pile or clump. And that's exactly what we have here. We have individual little clumps of water sticking together up there in the air. Those are called cumulus clouds. They are the classic cloud shape. They're what you think of when you think of a cloud. So once again, cumulus clouds are little white, puffy, cotton ball type shaped clouds.
Now, cumulus clouds, like the ones I just showed you, or the ones in this picture, tend to indicate nice weather because they're only really small little clumps of water, and they're not big enough collections of water to make it rain. Now, the exception to that is what we call a rising cumulus. These two pictures here are cumulus clouds because they're the white, puffy, cottony ball looking clouds. But there's something different about these, and that is that they are vertical. They're not flat, they're not round, little puffy. These are columns of cumulus clouds. And what this tells us is that the air in that spot is rising, hence the name rising cumulus. It is a vertical cumulus cloud that is growing upward. Well, you know, at some point up here, it's going to be cold enough for the cloud to kind of reach its saturation point. And at that point, it's going to drop all of the water that it's holding, and that's what causes precipitation. If we see a rising cumulus cloud, we know it's growing. It's starting to really suck up more air and suck up more water, and it's going to grow out of control, and eventually it's going to explode. Something like a typical Georgia afternoon thunderstorm. So if you see cumulus clouds that look like this, just know that the weather is going to be changing. This cloud is going to explode in a small storm.
So let's look at a different type of cloud. Notice the sky behind me is not clear. It's covered in a cloud, but we don't see individual, distinctly different clouds. Instead, we see where it looks like the entire sky is covered by one large cloud. This particular type of cloud is called a stratus cloud, and it comes from an old word which meant blanket or layer, and that's what we have here. We have the entire sky is covered in one large layer of clouds called a stratus cloud.
Now, cirrus clouds. Cirrus clouds are a little bit different. Cirrus clouds are described as being wispy, thin clouds. They're characterized by very thin shaped, almost transparent shaped clouds, which means these guys don't hold a lot of water. And you can see that these aren't very big, thick, puffy clouds. They cover up a very small portion of the sky. Well, what does that mean for our weather? Well, if we walk out the door and we see cirrus clouds, we know we're going to have fair weather because there isn't enough water in these clouds to really make rain. If I walk out the door, I'm going to play golf or go fishing, do some other outdoor activity, and I see these clouds, I'm feeling pretty good about the chance of rain being pretty low that day. Now, nimbus clouds, on the other hand. Nimbus is a prefix that means stormy. Nimbus clouds are storm clouds. These are clouds that have reached their saturation point, that are so full of water, they're getting ready to literally explode and drop all of their water. We see these a lot here in Georgia with our summer thunderstorms. Our clouds grow too big, too fast, and they blow up as nimbus clouds. So once again, nimbus clouds are storm clouds. Let's talk about where is it most cloudy in the USA and where is the least cloudy. You're going to notice that it is least cloudy in this part of the country, the desert Southwest. That makes sense because they get this continental tropical air mass, which is hot and dry. So if they have hot and dry, they don't have either one of the conditions it takes to make clouds, because you got to have water in the air in the first place, and it's got to be able to get cooled down enough. Now you'll notice it seems like the Northeast and the Northwest seem to be the cloudiest. Well, why is that? That's because they have those, let me rewrite that. They have a maritime polar air mass. So they have colder, already cold, wet air coming to them. And when it hits the ground and then is forced up by convection or by a front, it lends itself to making clouds. So they already have cool, wet air that's going to help that process. Here in the south, we're kind of in between. We're not a real cloudy location. And when we do get our clouds, they don't last very long because they form by convection only late in the day, which means, most of the morning we don't have clouds. So we're not a very cloudy location. We have the water in the air. What we don't have is the mechanism to make it rise, aside from convection, on a consistent basis to get us more clouds all the time.